Hi all, this is the practice problems from, this is the guided practice 18 from section 5.2 and 5.3 on exponential functions. So we've got here in number 4 where we're picking up from class where we're going to solve an exponential function. So remember back at the very beginning, we said that if we have the same base, then the exponents have to be equal. So if you have two expressions that are equal, and they have the same base, then their exponents have to be equal, okay? Now this one, we don't quite have that, so we're gonna have to adjust it a little. But if I look at 9 and I look at 3, the two bases, can I write 9 in terms of a 3? Well, sure, I can, because 9 is 3 squared. So I can replace my 9 with a 3 squared. So that would be the same as 3 squared to the x squared. And we still have the 3 to the 3x plus 2 over here on the right. Now, what do we do with exponents? When we're taking powers to powers, right? So this would really have some parentheses here. And so what we do with this 2 and this x squared is we multiply them. And that's going to give us 3 to the 2x squared equals 3 to the 3x plus 2. Okay. Now I have matching bases. So I have a 3 here and a 3 here. And that means if these two expressions are equal and they have the same base, then my exponents must be the same. So I'm going to be able to set my 2x squared, my exponent on the left, equal to the 3x plus 2, which is my exponent on the right. And now I've got an equation that I can go ahead and solve. So I'm going to go ahead and subtract my 3x and my 2 to the other side, because this is quadratic. So I can either try to factor, which I think I can, or we could use the quadratic formula here. But I'm going to try to factor because I think I can go box and circle on this one. So 2x squared minus 2 means my magic number is -4. I need two numbers that multiply to -4 but add to -3. So I'm going to go -4 and 1. And go ahead and factor the box. So this is 2x. And when I take that out, this is also a 2x. This becomes a -2. Uh-oh, this would have to be a 1. Something's not working there for me. So, all right, let's abandon that. I'm not sure why it's not working for me. Oh, wait, I lied. It does work. Hold on. Back the train up. There's no 2 here. Because when you take the 2x out of 2x squared, you have just an x left over. There we go. And then a -2 over here. So that means that this one factors as 2x plus 1 and x minus 2. And then we set each piece equal to 0. So we subtract the 1, divide by 2, and I get -1/2. And over here, we're taking x minus 2 equals 0. Add the 2 to the other side, and I get x equals 2. Okay, so the moral of the story on these is we want to get our base the same. And if there's not, it's usually because there's some relationship between the two. Okay, and then once we do that, then we can set the exponents equal to one another and solve. So that's number 4. Here we're going to graph y equals e to the minus x. So we're getting into our exponentials with ease, or the natural exponential function. And again, we're going to go 1, 0, 1, -1, 0, 1, 2, -1, -2. So when we plug in 0, we get 1. When we plug in 1, we get e to the -1, which is 1 over e. And when we divide that through, we get 0.368. For 2, we get e to the -2. That's 1 over e squared. And we get 0.135. Now, when we plug in -1, you get e to the negative times the -1 becomes e to the +1, or just e. So that's your 2.718. And then we want e to the -2. And that becomes e to the +2, which is 7.39. And we can go ahead and graph that. All right, so 0, 1 gives me this point, and 1.368 gives me this one, and 2, this one's way down here. At -1, we're up at almost 3, and at -2, we're way up here at 7. So it's going to look like this. Now notice, oops, let's see if I can do that again better. Notice that this one goes down from left to right, just like it did when our a was less than 1. Okay. And then lastly, we're going to find the zeros of our f of x. So when we do that, we set our function equal to 0. So you're going to have x squared e to the x plus 5x e to the x equals 0. Okay, the first thing I notice is that I see that both of these terms have an e to the x, so they have an e to the x in common. Let's go ahead and factor that out. What's left is x squared plus 5x equals 0. Now, normally, we can set each piece equal to 0. But if we were to set the exponential equal to 0, we wouldn't get any solutions here because we know that the e to the x graph does not cross the x-axis. So there is no value that makes it 0. So we would then want to set this one equal to 0. And this is still quadratic, so we're going to go ahead and factor out an x. And this is going to give me x equals 0. And this one will give me x plus 5 equals 0, or x equals -5. And those are my two solutions. So you typically want to factor out that e term. And that one's never going to have zeros, okay? So you're only worried about what's left in those parentheses. And we'll tackle the rest in class.